Hello and welcome to episode 8 of the Scientific Discussion, where we'll be talking to Parker and Ray from the Math and Physics podcast. They're students at the University of Toronto who certainly have a passion for the subject, and it's great to have them on. So what made you decide to start studying physics at a higher level?
Deep question.
All
What
right.
made you started?
It's very open.
Go for it, Parker.
Well, at a higher level, what actually got me into studying physics at a higher level was just I was going into business when I was in my senior year, and halfway through my grade 12, I went on the website for my university and I saw the program that was called Astronomy and Astrophysics. And I saw it and it just looked really cool. And so the next day I went into school and I just added physics to my schedule. And then that was kind of the end of it. I just got into physics.
Wow.
And then now I'm in third year.
That sounds cool,
I think mine is a little more of an emotional story, because there's little more of a story. Because after I watched the movie Interstellar in 2014, I was immediately attracted to the world of astrophysics and cosmology and space. And I'm like, well, what even is this thing? Right? So I was very, very, very curious just to learn about this vastness of the universe that I really knew nothing of at that time. And all I really did was just, with the help of Google, I just kept searching up different questions. What is a black hole? What is a singularity? What is an event horizon? And then that would give me a Wikipedia link that then let me go even deeper into these other things. So basically what that finally led to is, hey, to really understand what's happening in these black holes, I need to be taking up at least somewhat of a sophisticated physics course. So then I started searching for physics courses on YouTube. And I started following some YouTubers, and this is also a long time ago, so nowhere near the physics creators today. But I was just searching for physics content creators and courses and whatnot, and that's just that basically just got me super intrigued into just asking yourself, why does this happen? And then just figuring it out with the use of physics. So the ability for physics to do that is kind of what motivated me into being like, okay, you know what? I want to know how the universe works, so I think this is the most logical course to take.
Right, for sure, yeah. And I think a lot of online things are really important now. There's a whole generation of scientists coming from YouTube and things like that, which is great. There's a lot of outreach.
YouTube provides a lot of help for a lot of people these days, because it also allows you to get, number one, obviously free access, right? And number two, it's you have the choices are so abundant you can't even count them. So many choices are available. So really anyone, any field, any language that you are brought up in, you can probably learn that on YouTube, and that's really, really what's fantastic about it.
Yeah. Will, you have one?
Okay, so obviously the podcast's been going for about, is it around 95 episodes now? So why did you originally...
Yeah, we just posted 93.
Oh, yeah. So why did you actually decide to start it? Was it to kind of further your academic interest, or was it something else?
Oh yeah,
This is a
absolutely
question for
not. So, in first year of university where Ray and I met, oftentimes we'd be at parties or get-togethers, and then Rayhan and I would just talk about physics, and we'd have a problem set or some stupid question of oh, if you're in an elevator and you punch the wall, does the elevator move? And we just go on huge huge arguments about these questions. And then it's not until after we finished our first year exams, I had an idea. I don't even know where the idea came from, but I was just thinking, oh, let's do a podcast just talking about math and physics, because why not? We just talk about it anyways. And then Rayhan, of course, said, what, who's gonna listen to that? He said, how are we gonna talk for 30 minutes, because we started off by doing 30-minute episodes. And so Rayhan was like, no, we're not gonna do this. This how we're gonna, after we record like 5 episodes, what are we gonna have to talk about? But I convinced them to do it, and then now, now we just keep doing it. I guess we try to find
Yeah.
more and more things to talk about every week.
I think
Yeah, so to answer your immediate question, no, there wasn't any academic or any reason for why we started it. Like, oh, this is going to help us like this, or this is going to do this for our careers. It was just, hey, we just like to talk about math and physics, and especially during this time, COVID had just kind of gotten crazy, and like everything was in like online, and everything was going crazy. So we're like, you know what, we're anyways at home, so we anyways talk to each other about physics. Why not just record it? So that was the whole purpose. Now what it's turned into can obviously be used for our academic purposes, but that was not at all the intention.
So it was kind of like a way to kind of focus your passion for physics into like a perceptible
That's a
end
nice way to
product.
put it. Yes,
Yeah,
that's a nice way to put it. Yes, I would agree with that. Yeah.
Okay,
Alright,
so
And why did you guys decide to start?
I mean, we've had some friends that have started podcasts as well and had a bit of success with that. We have one friend who's got a politics podcast, and I kind of thought why not? And Will it's kind
So
of
you
the same
started a
thing.
podcast because your friends have successful podcasts?
Well, we thought like it's definitely doable. I thought like
Yeah.
and I know I listened mainly to you guys, and I was like, well, if they can do it, surely why not? We're a couple of years behind, but it's all good, and we're kind of the
That's
same situation.
definitely true.
Will is kind of, I was talking to Will about these sort of things as well, so it's kind of similar. You guys have been
Yeah,
It's all
100%.
about just outlaying what you're interested in, right? Like in your case, if you're interested in, well, I mean, if you watch our episodes, if you listen to our episodes, regardless of if we have the knowledge, we are quite heavily interested in the field that we're talking about. Like we put a lot of passion into it. So as long as you do that, it doesn't really matter. You will see people flock towards you. All right. People see the passion. People hear the passion in your voice. So if you have it and if you really want to make it, then people will definitely come towards you.
I've definitely seen that with yours. Well, you guys have been studying like a wide range of things within physics and maths. What have you enjoyed studying the least and the most in your time at university?
Well, the least is probably in first year. I don't know if this counts, but I had a bunch of electives in first year, and I had one class that was an essay writing class, and I just did not like that class whatsoever.
Yo, he said math
had
and
nothing
physics.
to
What do you
do-
like the least?
Oh,
I mean,
math
yeah,
and physics
anything
related?
counts as well, really, to be fair.
Okay. Okay, math and physics related. I don't know, to be honest. I feel like every math and physics related course was like contributing to like the pool of knowledge that I have now. So it's not really like I could go without one of the courses that I've taken before. Maybe like I guess if I could go back to high school, like I didn't like my high school courses just because they were just bad in general. But everything in university was pretty good. And I think my favorite is probably there's a lot of close ties for like the best course that I've taken. But I think I'd have to say like multivariable calculus. The one that Ray and I took was just such a good course, and I learned so much that like, and it applies in literally every single other course that I've taken since. And so I just think it's such a big course that it's probably my favorite.
I could definitely agree with the. I don't think I have like a least. I mean, well, there would obviously be a least, but I'm saying like I don't have a course that I didn't like, especially in university, because as you very rightfully said, every math course, every physics course, in some way contributed to some other course, right? And especially with the courses that we were taking, it wasn't anything light, so there were all like requirements. For example, 4-hour programs. So I mean, if they weren't fun, like, or if they weren't actually contributing for the course, then they wouldn't be requirements in the first place, right? So yeah, actually saying, I don't know if I could find a least favorite. You brought up high school, so I could definitely just copy you with that answer and say I could definitely see some high school math courses that could have definitely been made or just taught a lot better to prepare you for university. But no, obviously not. It's very, very basic. So you come into university and you're just completely thrown aback, especially with the level of math that we did or that any physics student would do at a first year university math class. Significantly more complicated than what you do in high school, right?
I actually
So
don't
there's a
think that's
big,
true,
big,
Ray.
big jump. What from first year math, like 137 from high school?
No, I don't think every university does like proof for like requires
Oh.
proofs for physics.
I'm pretty sure first year. I don't know actually. Okay, I'm not sure anymore. Okay, I'm not sure anymore. But if you are taking a multivariable calculus course, or a calculus course that has some amount of rigor, some amount of analysis is the word, the real analysis, then you'll basically be seeing quite the large jump, but also quite the large interest because the intuition that this kind of course provides you by understanding the proofs, by understanding how this formula works. Because, throughout high school, we work with derivatives, we work with integrals, we work with these things, and we're like, okay, I understand how they work, but I don't understand why they work. Now, again, you might not be interested in it, but then you might not be a physicist. So you guys obviously would be. So for someone like you or anyone who's really interested in the science field would want to do some sort of analysis, which is why I say the high school definitely bogs it down too much. So if I want to say least favorite, I would maybe say any course from really high school. But it definitely is a big change in university, and I definitely would also recommend these to be taken in university. And a favorite in university, I would actually have to say, interestingly enough, quantum mechanics. Our second year introduction to quantum mechanics was maybe one of the best teachers that I've ever sat in a class for.
Oh,
One of the
for sure.
best explainers. We also had him on our podcast, The Heart of Quantum Mechanics. It was a really cool episode. And this guy, the way he explains, the way he teaches, I've never seen a teacher like that. Never heard a teacher.
Yeah, it
So
was insane.
I would say mainly because of him, I would say my introduction to quantum mechanics was my favorite course by far.
Sure, yeah.
Because
I thought you were
mainly
gonna
because of the
say
teacher.
experimental physics.
That would be my top courses for sure, but the understanding of the quantum world, again, I know compared to what you've done, Parker, in third year, it's nothing. But I'm saying just the very introduction, the just being introduced to understanding the quantum world, like the very various things, energy levels, infinite welds, all these wave functions, understanding that you can make any system really into a quantized system and understand it in terms of probabilities. Just that intuition, just that understanding was the most crucial to me. If you're talking about most fun in a course, yeah, probably the experimental physics course, because I had a lot of fun in there. But when you're just talking about which one did you enjoy the most, which one did you learn the most, I should say, that would definitely be my first introduction to quantum mechanics.
Yeah, I guess continuing on the theme in the transition from high school to university, what tips would you give to a physics or math student just about to enter university?
That is a good question, and it also depends on what you're going to study and also which university. Because I don't know, I was gonna say unfortunately, but I guess this is kind of a good thing that Ray and I were thrown into writing proofs in our calculus course without any warning. So first year I thought we were just going to go into calculus and it was just going to be exactly like high school, but just like whatever comes next. And then all of a sudden we're in math class like doing sentential logic and learning quantifiers and writing down like formal definitions of things, and I was like, what is actually going on right now? I had no clue. So if you know for sure that you're gonna go into like a proof kind of stream, this is all I always recommend the exact same thing. I recommend to read the book called How to Prove It by Daniel Vellman or Dr. Vellman. It is just such a good book. I ended up reading it in the summer after first year, and going into the following calculus class, which was still writing proofs, but this time like multivariable calculus, I just knew right away what was going on, because when you understand kind of how you actually write proofs and how you use the assumptions to your advantage to follow very logically from one point to the next, you can't really get lost, because you just understand kind of how one step leads to the next. And so yeah, I definitely recommend reading that book. Also, if you're just going into physics, like go on like Khan Academy or something, or go on YouTube and just watch a whole bunch of videos on like every single topic, because you're in first year you're gonna be seeing everything, but just at a basic level. And so just make sure you kind of know what you're getting into and be ready.
One thing I would say would be, I mean, obviously very similar, just adding on to what Parker said. Look at the courses, that you're going to be taking. So that's always the best thing to do, in my opinion, is to literally look into the university that you want to get into. Let's say you have a goal university, you're moving from high school, and you're like, okay, I want to get into Stanford. You're like, okay, let me look at the Stanford courses for physics. Now I go to the Physics Stanford website, there probably exists one, and now look at all the courses that you have to take. And then under all those courses, look at the syllabus, right? Look at the requirements, look at what they do in the courses, right? And the amount of work, the amount of material that is available on the internet, right, that is all open source, is just amazing. All of these courses almost definitely have very, very, very public syllabuses, right, that you can all find. So you can all find the textbooks that are required. I know, I was thinking about that too. I'm not sure if it's syllabus,
right.
But
I don't think that's
right. I don't know about that either. But point being, you can find the syllabus for any of these courses online. That allows you to read what they do in the course, what textbook they use, what are the different chapters that they go through, right? And if you're like, hey, I have a summer break before my university starts, what do I do? Well, this is exactly what you do. You'll look at all the courses that you have to take, and you're like, hey, why don't I just brush up on some of the material that I should know before taking the course, and then actually learn the course itself? So that when you go into the actual university setting, and now you're asked that, you're tested on this material and whatnot, you actually have not only the understanding, because you've already done a little bit of it, a little fundamental before, but you also have some extra practice than a lot of the other students. Because while you would have been doing it in the summer, the goal is that you will actually be practicing a lot of this work, right? So just doing these things in advance, in my opinion, definitely helps, especially when your subject is relatively complicated, such as this one. Because again, as we keep mentioning, it can get hard. It can get hard really fast. So to prevent that from happening and to prevent you from not understanding it, just do it before. Just do it beforehand, or at least understand the basics beforehand. So that's, I think, a really nice thing for people to do.
Yeah. So it's kind of like a be specifically prepared for your course type of thing.
Yeah.
Especially because most people have a decent idea about what they want to do, right? Or at least what they want to get into. Like, okay, I want to get into physics. I don't know about which physics courses I want to take, but I want to get into physics. So just read up on all the physics lectures, right?
Yeah. So obviously in the past you've done quite a few episodes on science, kind of physics history, with like a few recent ones on like Galileo and Kepler and figures like that. So do you have any specific like science or physics role models, or who have like kind of like inspired you, I guess?
I really
I have an
like
answer.
Niels Bohr and also Einstein. The reason I like Einstein is because he wasn't particularly he even admitted himself that he wasn't mathematically inclined, and he just had passion for the subject, and he was able to visualize things really well. And I always like to think about that when I'm feeling really stupid and I can't answer a question. I'm like, oh, it's okay, it's gonna be okay, as long as you're interested in the subject, you can do great things. And also Niels Bohr, he's just like I love quantum mechanics, and so everything with the Copenhagen interpretation of quantum mechanics. And even though I've been reading a book on quantum mechanics recently, and I'm shying away from being a Copenhagen boy. I kind of like the many worlds interpretation a little bit more now, but nevertheless, Niels Bohr is one of my favorites, especially because of the interactions between Bohr and Einstein during that period of like 1927, where they were having like the conferences on quantum mechanics and all the arguments and the thought experiments. I think that was just great.
So I've always been intrigued with teaching, and a big part of me learning science originally was like I have these two whiteboards at home, so I would just act like a teacher, and I would kind of like teach myself this work, like especially when it was something that was way out of my scope. I would be like, okay, I'm not gonna just read it on YouTube. Instead, I'm gonna like act like a teacher and teach it to myself, because when you're teaching, you have this ability, or not this ability, this want to explain everything in a very fundamental manner. And if you know any scientists, by how I've just described it, one of my biggest inspirations was Dr. Richard Feynman. So he is probably known. He's the counter example to the quote, "Those who can't do teach." He's the direct counter example, because he did and he taught very well at both, very well at both. So Richard Feynman, I mean, if you know anything about him, was a phenomenal teacher, because he had the ability to understand these very complicated situations and explain it in a very simple manner. So a lot of times what I like to do, I like to talk to my grandparents about these really complicated physics topics that they probably will never understand or care about. But my grandpa, for example, he actually is somewhat of a scientist, and not now, doesn't really care anymore, but every time I'm thinking about a really complicated topic, I'm like, oh, what would he think if I explained it to him like this? What would he think? And I think that understanding that, bring it down to the basics is really important. And that all came from Dr. Richard Feynman. Super big inspiration.
Sure.
Yeah.
To me.
You also earlier mentioned how high school math and physics wasn't the best. How do you think that math and science education could be done better? Yeah.
I think if they would have logic courses in elementary school along with math courses, and all the way up until the end of high school, that would make everything a lot better, to be honest, and it would make people just smarter in general, because math has
I
a
think
lot
the problem
to do.
with logic courses. No, okay, continue. Sorry.
I was gonna say that math has a lot to do with logic, because it's just a whole bunch of axioms, and then everything comes from the axioms. And so what you're actually learning in high school is not math, it's applied math. You're using the things that people do in pure math, and you're just applying it to situations. Now, the teachers don't tell you that that's what you're doing. They just say, oh, this is math. Add two numbers together. Well, adding two numbers together is, quote unquote, not actually doing math. It's just applying the math that we already know into situations, like 5 apples minus 2 apples. And I think it throws people off. It definitely threw me off going into university, where I, somewhat got a look into what real math was. I just thought I was going to walk into class and then, do an operation or something. They're going to introduce this new squiggly line, and it'll be like, oh, well, you just follow some rules, and then you, for example, just integrate, and you just follow these rules, and there you go. But math has little to do with following rules, and more to do with just using your imagination and being like, oh, look at what I can do if I want to, for example, calculate the area under this curve. How would I be able to do that? How do I actually define this rigorously such that it makes sense? And if I find weird counterexamples, like extremely discontinuous functions, how is the area even defined under that curve, or like the issues with negative area. Anyways, I'm pretty far from the question now. I think what I was trying to say is just introduce from the beginning what math is really about, because I don't even like high school math, and I'm like I do math and physics as, I guess I wouldn't really say my profession, but I'm a student, so I guess it's my entire life right now. And it's hard to really fall in love with math while you're in high school, because it's not actually what math is. And so I think if they just change that up, that would be way better.
I think the problem though is that logic. I don't know if that can be or should be introduced too early too, because like I don't know. I think I remember talking to actually a professor about this. I believe it was Zach actually, and I asked this very similar question. I'm like, would you not teach these logic courses in high school? And it was basically, the answer was somewhere similar to, it's a little bit too abstract for such a young, immature mind. And it, that does hold some truth to it, right? Like, but I still definitely do agree with you, Parker. Like, there should be a little more introduction of some more sophisticated levels of math, or not even sophisticated levels, just math. Because as you put it really well when you said high school is applied math and it's not math, right? And that is exactly what it is, right? So the whole problem is that we go these 4 years thinking that we're doing math when it actually isn't, and then we're thrown into the real math and we're like, oh, this is very different. So some people can get completely deterred by looking at the real analysis in university and be like, oh, this is really hard, or I really don't want to do this because I don't like this anymore. Because I know so many people that were phenomenal students in math in high school, but then they go to university and they, that is not holding anymore, right? Because it's a completely different way of thinking. It's not the same level of math. So a little bit of an introduction would always help. But I think the common thing is that in high school, it's interesting because it also depends where you are. You know, different high schools teach different things, because I also have a little bit of experience from an Indian high school, because I went to India, and over there they do things very differently. Very differently. If you leave high school over there and you come to university over here, you will be perfectly fine. You will actually maybe have more knowledge coming into university here. You will probably be okay. But coming from a university anywhere in a high school anywhere in North America, I mean, again, I have experience with this, it is not the same thing. Basically, what I'm trying to say is that different high schools have different levels that they teach you at. And the problem is, at least to our understanding right now in North America, the level is too relaxed. Everyone's too calm. It's like, no one really cares about studying, and people are still getting 85s and 90s, which is okay. But again, you're not really learning anything going out of high school. There are so many people in North America. Again, I'm using North America as an example. I know you guys are in UK, but it's the only thing I know. But in North America, there's so many people that leave high school and they're like, I don't know what I want to do. Of course you don't know what you want to do, because you weren't challenged anywhere. Everything that you did was just it was just relaxed. It was so calm, because that's the environment for high school, right? But because you weren't really challenging yourself, you weren't challenging your mind anywhere, which is why you don't know what you're interested in. So the problem, or the advantage I could see that high school may be able to pose, is like specialized courses. Like the AP program, for example, or like the IB program, or like, like programs that have these specialized courses are really interesting, because they're like, hey, if you're interested in it but want to take the step further, come to this particular program. So, I really like those specialized types. Clubs are huge. If they could increase, I'm not saying make clubs mandatory, but I'm saying maybe make it a little more interesting. Maybe put a member of faculty, maybe put a member of staff into a club. Like a physics teacher should be running a physics club, right? That wasn't even the case in my school, so which is ridiculous. But I'm saying, if that's the case, maybe the physics students needs to have like 1 or 2 mandatory club lessons, and then, you know what I mean? Like, I'm just saying, make it a little more fun, interactive, and challenging for the students, so they actually see a need to do more. Because if it's just easy the whole time, then they're like, okay, there's no need for me to get into this field because I already know it, or at least you think you know it. You know what I mean? So that's kind of the common problem with high school, that it allows you to think that everything is okay when it really isn't. I don't know I don't know how good of an answer that was, but hopefully
No,
hopefully
makes
that
sense,
answered your
makes
question.
sense. Like, I think
Hopefully,
maybe
okay, that's
to have
good.
some more,
That's good.
specialist things is important. Like, to
Yes,
find out
yes,
what you
I
actually
think
enjoy.
so.
Yeah, rather
Mm-hmm.
than just kind of tick boxes almost in the syllabus.
Exactly, right? Exactly, my
Uh,
point.
so you mentioned before the How to Prove Things book, I think you said. So do you have any further kind of physics or maths like book recommendations?
Um, okay, there's one book. I forget the author, but it's called Infinite Powers. I'm gonna Google it right now. And I read this out of high school before, or actually no, I read this, I think before taking calculus, and so I had no idea what he was like talking about. It's by Steven Strogatz, and yeah, he just talks about like how calculus, just like calculus in general, like the history of calculus, how you can apply calculus in different areas, and just a whole bunch of interesting stuff. And I really enjoyed that book. Other than like in terms of physics books, anything like if you just Google like quantum mechanics, like books on quantum mechanics, like anything in that field is gonna be like very awesome.
No, but again, I don't know if it's like, okay, the book How to Prove It like really gives you a good understanding, but the thing with a lot of books, like to read books, like textbooks are different, but I'm saying to read books, the problem is that sometimes you're spending like 2-3 weeks on like this one book, and sometimes there are many more resources that you can spend a lot less time on and learn a lot more. Because the way I like to learn things is kind of, you can think about it as knowledge per time, right? You want to maximize the amount of knowledge per time. That's what you want to do. The problem with
This guy's
books
such a nerd.
is that, bro, I mean, that's literally how I work, bro. Like everything, like the reason I don't, and this is it, the reason I don't read physics books is because of this exact reason. I can learn the same material in a 2-page report, like a complicated report, right? Okay, maybe not 2 pages, but you get my meaning,
Okay,
right?
I actually
Like I can learn the same
disagree
thing in a
lot
book.
with what you're saying.
You don't agree that you can, because the problem with a book, or not the problem, but the issue with the book is that it goes, it at the end of the day, it's trying to be like a continuous story, right? And
that's the
sometimes
point,
you
though.
can
It's meant to
learn
be
the same
entertaining.
material. Yeah, no,
But
that's
it's
what I'm
meant
saying.
to
So
be
I'm not saying it's a
entertaining.
bad thing. I'm not saying it's a bad thing. I'm not saying it's not entertaining. It definitely is way more entertaining reading a book than reading a report, 100%. But I'm saying that if you want to maximize the knowledge per unit time, then in my opinion, books sometimes tackle individual fields, individual subjects. Like, let me give you an example. A Brief History of Time. One of the best physics books I've read, right? But again, if you're talking about the knowledge, like all over the place knowledge. But if you just search up on a Wikipedia article the information that they talk about in that book, you can basically find all of it on one article, right? Like the arrow of time, the singularity, like a lot of it can be found in 1 or 2 or 3 articles that can be basically read in the span of maybe a day, right? Instead of spending like 2-3 weeks. So again, I'm not saying it's bad to read books. Do not take that away from what I just said. All I'm saying is, because you asked what other books do you recommend. Now, if you want to read it just to entertain, just to be passionate about it, books are phenomenal. There's so many. You can just search up science books, or as Parker said, just quantum mechanics books, and you'll have a blast. But if you want to learn, maximize your learning, and you're like, hey, I have school coming up in the next month, and I just want to learn as much as I can before school starts, then that's where I don't recommend books, right? And that's where I say the online resources are way more useful to use, right? That's one thing. Like textbooks, for example, textbooks that have particular chapters that go in depth into certain fields. You can search up textbooks, as I said, with previous courses that you want to take. So those textbooks actually go really deep into certain things. And that is where you can really learn. But just books on it, again, it'll make you have fun. You'll have fun. I won't say you won't. But if you want to maximize your knowledge per time, not exactly books. That's what I think.
That's definitely true. I think I've learnt more from Khan Academy than I've learnt from any book I've ever read. So.
Right? Khan Academy is the reason I'm here today. And that's no joke. That is no joke, right? Khan Academy is why I'm here, because of all of their courses. And literally in a few videos, in 2 videos, you can learn probably what a whole book takes up, right? Is what I'm trying to say. Yeah. So that's the advantage of using other resources.
If you could be a physics or math researcher studying one thing, what would it be?
I already have my answer. Dark matter. Dark energy, actually. Dark energy.
Oh, I was going to say that, actually.
Yeah.
Dark energy
dark matter is so cool. Dark matter, you think?
Yeah, I would say dark matter. Actually, I was thinking about it recently because I kind of have to choose what I'm going to do in grad school. And I was thinking the coolest thing that I can think of is trying to like build a field containing like dark matter, quantum mechanics, and like black holes. If I can like combine those 3 things, that would be crazy.
I mean, the problem right now is that general relativity does not combine with quantum mechanics in these singularities, right? Which is where all these other theories come from. Like loop quantum gravity, string theory, and whatnot. Like all of them come from that one fundamental. So that would be like what you're basically describing is a theory of everything. You just said you want to.
What I personally believe is that I personally believe that dark matter and dark energy is kind of the key to like bridging general relativity and quantum mechanics together, and so kind of looking out into space and doing like what am I trying to say? Like,
well, you're also talking about dark energy, not dark matter. Dark matter doesn't have anything to do with bridging these 2 things together.
No, I mean like the 2 together. You know what I mean?
No, I know what you mean, but I'm saying like a field. Like again, the whole point of this field, a field can't just reconcile 2 different theories.
No, I'm not talking about
like
a field. I'm talking about like a field, as in like something that you're studying, like in a field, like.
Oh, I thought you meant like field, like a tensor field, like an actual field in space. Oh shoot. Okay, you're saying like field of study. Oh, yeah. Okay. No, that would definitely be cool. Okay, field of study. Yes, that makes more sense. That would be very interesting. Dark. That would definitely be cool if those can be reconciled. In my opinion, answering my part would be dark energy. Again, very, very, very different from dark matter, and basically makes up like 75% of our universe right now. So, observable universe right now. So, understanding or even, your question was what would you research? So yes, I would research dark energy because this is the one thing. Like, out of everything that we know nothing of, this is the most that we know nothing of. So it's the one field that we know least of, I should say. So it would be very interesting, definitely much harder, but very interesting to see where I could go.
Yeah, so what thoughts do you have on kind of an upcoming like avenue of discovery? Obviously, well, in physics or maths. Obviously, with the launch of James Webb, there's obviously going to be some more of these coming up. But kind of what would you like to see, almost?
I mean,
so
I'd like
the
to
muon
see...
experiment. Okay.
No, you go.
1 second. The muon G-2 experiment was that was just taking place this year. Showed with a very high probability that our understanding. Oh, sorry. Are you guys familiar with the muon G-2 experiment?
I've listened to you guys go over it. Yeah.
Yeah, beautiful, awesome. So the muon, it basically showcases with a very high chance that our fundamental understanding of the standard model, so basically reality itself, is wrong, right? Something is incorrect with our theoretical understanding of the world. So this year or like in the future or whatever, I think the biggest things will be, because this year actually that experiment I believe is being repeated once again, and just to be confirmed, we spoke with the head of the laboratory that other in an episode, and he was talking about how next year or the year after it's going to be confirmed basically whether our predictions made sense or not, right? So something to that level. Now the James Webb, I know you specifically asked for James Webb, but I think that will also be able to help in the very same field, because the James Webb is looking at the time, close to like recombination, like close to the time in the universe when all these particles, all these fields are getting together. The first light of the first star is just being emitted, and it has the ability to see all the way back there. So if we are able to, maybe wrap up or get a better understanding of the theoretical inaccuracy, like what went wrong there, we would hopefully also be able to experimentally observe that with the James Webb. So I think, again, I'm not entirely certain if they are looking at the same time periods, but maybe at least some kind of help will definitely be provided by the observations made from the telescope. Because I think the biggest thing that to happen this year is this muon G-2, is the fact that our standard model of particle physics is actually inaccurate, right? So any kind of light that is shed onto it will really, really change the way we look at physics today.
It's like literally light being shed onto them.
Literally light, yeah. Literally light, yeah.
Which is actually insane if you think about it. Like, there are photons traveling through space that literally come from the very instant that photons were allowed to just travel freely through space without running into a bunch of electrons and neutrons. I think that, like, being able to literally see that light it'll unlock doors that we don't even know are there yet, and so it's hard to make a prediction about, what do I want to see come out of the James Webb Telescope. I mean, I guess I want to see the entire universe get solved, but I don't know how successful that's going to be, but like 100% we're going to see some very, very interesting observations being made. And I'm pretty excited to see some cool pictures.
Pictures will definitely be cool.
We've got basically one last thing. What are some of the plans for the podcast in the future, and like what might be some of your next episodes to look forward to?
That's a good question.
Well, we like for just the episodes that we record, like just the regular episodes, we usually just think of something that would be interesting to talk about, and then we talk about it. So we don't really plan it ahead that far. But I think, like, in terms of those episodes, maybe, like, talking about, like, chaos theory, getting more guests on for sure to talk about, more about quantum mechanics, more about...
Exactly.
And even more about, like, metaphysics related topics, like get like a professional neuroscientist to come on and talk about consciousness or something, because it's still, at the end of the day, everything that is in the universe is something connected to physical reality, and so I think anything is fair game, and I'm really interested in that kind of stuff. So maybe branching off and doing like less directly school physics type topics on the podcast would be very cool.
Yeah, no, I definitely second that. More guests is definitely one thing that I want to see. I don't know. I mean, we'll hope. We're always lazy though. Like, because I mean, at the end of the day, getting guests on, they're not just gonna pop up. We have to email them. We have to get them on, right? So sometimes laziness does get a better of us. Not laziness. I should also say school. Like, we also have work on the side, so a lot of things do come in the way. So sometimes we just have to make do with what we have. But yeah, I think the less schoolwork physics and more general physics, how the world applies with physics and whatnot, like, applying it to the real world. like our how blank even exists playlist that we have, like how this even exists, how that even exists. We like basically like philosophy
It's called
episodes.
Does Blank Even Exist?
Sorry, does blank even exist? Sorry. Does blank even exist? Sorry. Does blank even exist? And the point again of all of this is basically, as you were saying, anything in the real world is fair game because we can make it fair game, right? Anything that is even neuroscience, like even like neuroscience, we can make it into a discussion on physics, right? Like anything that we see in the real world, we can always bog it down to the fundamentals, which then figures out in some way of math and physics. So it's not terrible to pick really any topic that we can just take down into the world of science. But I don't think as Parker just said, we have nothing specific planned. Just guests and yeah, basically hoping that we can branch out into a little more topics that we're also interested in. Like consciousness, I think, is a very popular one that we are, or like aliens, for example. We had
Oh,
we
yeah.
had
yeah.
the
Building the pyramid.
we
I
had
like
the
it.
former we had the founder for what do you call it, for SETI on there, who we were talking about aliens and whatnot, right? So any current researcher who's researching or dabbling in any extraterrestrial objects, even something like that would be cool. So I think the biggest, to answer your question, basically the biggest thing that we're hoping for at least is more guests. More guests, I think, will really solidify the podcast because again, that we just have different things to talk about, different people to talk about this too, and just branching out in more topics, that we can then bring down to the world of physics.
Oh, that's great. Yeah, that's about all we have. Yeah.
Oh, thank
great.
you
Yeah,
so much,
it's
guys.
It's a great conversation.
Having us on.